So let's see if we can find the first four positive solutions here exactly and approximately. We can check it on a graph. So recommended way I proceed here is to first solve for the trig function. In this case, I'm going to solve for sine. Just divide the 6 to the other side. Sine pi over 2x is equal to 2, 6. 2, 6 is really 1/3. And I pause here for a minute. And since this is more than just a single variable in there, I'm just going to say, well, let's just call that theta for a moment. And then just imagine, when is the sine of theta 1/3? And so then I think unit circle. On the unit circle, the sine is a y value. So right about here would be y equals 1/3. So that's going to lead to this point there, or that point there. Now this point here, let's say that's theta 1, that's what the arc sine is going to tell me. So the sine inverse, the arc sine of 1/3 is going to be that angle right there. This other point has this blue angle, but that blue angle has a reference angle that is theta 1, but going in the other direction. So my claim is my blue angle theta 2, oops, let's make that blue, theta 2, that's going to be pi minus my first angle. So that one's going to be pi minus sine inverse of 1/3. So I have two solutions here to the sine of theta. Now I don't want theta, I want x. So now I got to take my next step, right? So this was step 1 right here. Step 2 for getting an exact answer is to finish off, deal with that pi over 2x. So for my first solution, in my step 2 here, I have pi over 2x equals the sine inverse or arc sine of 1/3. To get rid of a fraction, multiply by the reciprocal. So that means x is going to equal 2 over pi times the sine inverse of 1/3. Now that is a positive angle, so I have the first of those four positive angles right there. My second one here, I have pi over 2x equals pi minus the sine inverse of 1/3. And then I multiply by the reciprocal, so x equals 2 over pi times pi minus sine inverse of 1/3. So there's the other, that's the second of those four positive solutions I'm looking for. Now, once I get down to here of x, I just need to consider what's the period of the sine of pi over 2x. Now the 6 on the outside, that just changes the amplitude, no big whoop. Period is related to the multiple of x here. So the period here is going to be 2 pi divided by that multiple, which is 2 pi times 2 over pi. Pi's divide out, and I get a period of 4. So then I can extend either one of these solutions by just adding or subtracting the period. Now, if I'm looking for positive solutions, then I'm going to add the period. So I have this one right here, we're going to call x1. This one right here, we're going to call x2. And so then x3, the next one will be to take the first solution, 2 over pi times the sine of 1/3, and add 4 to it. That's going to give me the next solution. And then take the second one here and use the period. So my fourth solution is going to be this crazy one there. And you can multiply that 2 over pi through, but it really doesn't make things any better. So I'm just going to leave it as 2 over pi parentheses pi minus, and then add 4 to that. So I'm going to use Desmos to check those. And so in my check, right, I'm going to calculate each of these numbers, and then I'm going to plug in to this side right here and hope I get a 2 as the answer. And then we'll look at the graph to see if it makes sense. So definitely want to find ways to check our work. Let us reload this page. Start over. There we go. So I think my first solution, I'm going to call that one A, is going to be equal to pi over, no, 2 over pi times the sine inverse or arc sine of 1/3. Let's make sure I type that right. So that gives me a radian angle of about 0.2. Looking at my graph. Yeah, that's pretty shallow there. One radian would be about here. I'm down there. Yeah, that seems reasonable. So let's see, 2 over pi times the, oh, that should say sine inverse there. That's the problem. Sine inverse or arc sine. So that's my first one. That's my A. And my B was to, well, that was a little bit of work, so I guess I just have to type that one out. B was that 2 over pi again times parentheses pi minus that number for A, pi minus, no, it wasn't A, it was just the arc sine of 1/3. Double check my notes, make sure I type that right. Yep, and I'm using arc sine instead of sine inverse. They'll both give the same results. If you're not sure, we can double check that. Compare to answer A, if I do the 2 over pi, use the keyboard this time, there's pi, arrow over, and then times the inverse sine of 1/3, you'll see I get that same number I have above. So this calculator recognizes arc sine as equivalent to sine inverse, which it is. And then otherwise, to get other solutions, I just keep adding the period, and I calculated that the period here was 4. So the next solution down the road should be solution A plus 4. So about 4.2-ish. And the one after that should be solution B plus 4. And so that would be about 5.8-ish. So my first 4 positive solutions ought to be about 0.2, 1.8, 4.2, and 5.8. So checking those, we get a couple of things. We type the original left side, and the original left side said, I'm going to use function notation, f of x equals 6 times the sine of pi over 2 times x. And now, since I'm using function notation, I can say, okay, what is f of my solution A? F of A, 2. What is f of B? 2. What is f of A plus 4? I didn't give that one a name, so I have to type A plus 4. It is 2. Now, the period is 4, so 2 periods would be 8. So what is f of A plus 8? It ought to be 2. What is f of B plus 4? 2. Now, I could also go minus the period, B minus 4. That would give me another one, 2. All right, and my original, let's get rid of that for a second. Again, said when is this function here equal to 2? So I could just graph y equals 2 to double check my first 4 solutions. I have the exact versions here and here, 10 plus 4. So if we also graph y equals 2, we should see those first 4 solutions here. So the first one should be about 0.2-ish, there it is. The next one here should be about 1.8-ish, there it is. Next one should be about 4.2, and the next one here should be about 5.8-ish. So there it is. Now decimals only gives me 3 decimal places. If I want more decimal places, right, that's where I have to do all this work right here. And so I can get as many decimal places as I desire, depending on the problem. Solved and checked.